One of the most common applications of dynamic programming is in allocating resources to teams, and that is what we will cover today. In linear programming, the entire solution can be arrived at in one step. However, it fails when the increase in outcome is not linearly proportional to the resources deployed. In such cases, the decision is taken in steps, and the decision at a certain step is connected to what happened at the previous stage. This is best explained by an example. Let us say there are 3 territories, A, B, and C, and we need to take a decision to deploy 5 salesmen. The sales in each territory as a function of the number of people deployed is estimated. As we can see from the table, it is clearly not linear. So, in the first step, we just consider regions A and B and work out the best way of allocating the people, assuming first that there is only 1 person available, then 2, and so on. So, for example, if we have 3 people, we can allot them in 4 different ways: all 3 in A, all 3 in B, 2 in A, and 1 in B, or 1 in A and 2 in B. For each of the options, that is assuming we had 1, 2, 3, 4, or 5 people to deploy, we make a note of the maximum sales possible in territories A and B. In the next stage, the comparison is with the combined best of A and B versus C, and we basically look at just the case where a total of 5 people are deployed. Again, here we have 6 possibilities: all 5 in C, 4 in C and the rest in A and B, 3 in C and rest in A and B, 2 in C and 2 in A and B, 1 in C and the rest in A and B, or all 5 in A and B. This gives the result that the best combination is to have 4 people in A and B and 1 in C. From the earlier step, we know that the best way to deploy 4 people across A and B is to assign 1 person in A and 3 in B. So, with the final allotment as 1 in A, 3 in B, and 1 in C, the total sales is 170. Let us try out a similar problem in today's assignment. The data is given in the table, and we need to find the optimal allotment of resources to maximize sales. In the first step, we start with regions R1 and R2 and find the best combinations if we had 1, 2, 3, or 4 people to deploy. The best combinations are taken forward. In the next step, we add the data for R3 and arrive at the best combination. The final allocation is 1 for R1, 2 for R2, and 1 for R3. The total sales is 105 units. This example is the most intuitive one when it comes to dynamic programming. Next, we will look at a situation where probabilities are involved.